Hi everyone! In this video we're going to look at a few more examples where we need to compose two functions, but this time not all the functions will be expressed using equations. Some of them will be defined by graphs and tables. This time we need to find composition of function f and g at a certain value. It's 2. Using the given representations of functions f and g. So in the first case, both functions are defined by equations. In the second case, functions are defined by graphs. By the way, these are not the graphs of the given equations. And in the third case, both functions are defined by tables. Let's see how this works. First, let's use functions defined by equations. To find f composed with g of 2, again, I'm going to write this out using definition. F composed with g of 2 is the same as f of g of 2. That's how the composition operation is defined. So the only difference with what we did before is that before we had x in this place, and now it's not x but a specific x value. Next, I need to evaluate what I have inside the parentheses. Inside the parentheses I have g of 2. How do we find g of 2? Well, by plugging in 2 into function g. I'll do this work on a side. So g of 2 equals square root of 2 plus 7. That is square root of 9 or just 3. Okay, that means that g of 2 should be replaced by 3. So my next step is to write f of, and instead of g of 2, I'm writing 3. And what I need to do next is to find f of 3. To do that, I'll simply plug in 3 into function f. So that is 3 cubed minus 1. That's 27 minus 1, which is 26. So f composed with g of 2 equals 26. Let me illustrate what we just did with this picture. We were given x value 2, we plugged that into function g and found that g of 2 equals 3. And then 3 was plugged into function f. And that's how we found 26. So that's what happens when we compose two functions. And that's the path that the original input takes. Now let's try the next example, where we have functions defined by graphs. Once again, we need to find f composed with g of 2. And that is the same as f of g of 2. And again, first we need to find what g of 2 is. Well, for that, we're going to use the graph. Remember, 2 represents x. So on the graph of function g, we have to find point with the x value 2 and see what its corresponding y value. Well, here's 2 on the x-axis. If we go down to function g, that's going to be the point. It has coordinates 2, negative 3. That means that g of 2 is negative 3. So we're going to replace g of 2 with negative 3. So g of 2 equals negative 3. And next we need to find f of negative 3. So for that we're going to use graph of the function f. We need to find point on this graph such that its x value is negative 3. So here's negative 3. If we go up to the graph, here's going to be the point. And it looks like the coordinates of that point are negative 3 and 2.5. Let's write like that, 2.5. Which means that f of negative 3 equals 2.5. And that's going to be our answer right here. So f composed with g of 2, in this case, based on the new defined functions f and g, is 2.5. Again, all these three examples have nothing to do with each other as far as the definitions of functions f and g. We kind of start from scratch every time. And let's try it again, but now functions f and g are defined by tables. Again, these are not the same functions f and g as we saw in the previous examples. And I always start by writing out what I need to find, f composed with g of 2, and writing out it using the definition. It's f of g of 2. And I start working from inside out. So first I need to determine g of 2 using this table. Okay, let's look at the table. In this table, we have the x values given in the first row. Then we have the corresponding function values or y values. For f, it's the second row, and for g is the third row. So now we need to find g of 2. Input 2 is right here. What's the corresponding output for function g? Well, it's -1. So basically here we have x value 2 and it corresponds to the y value -1, or function value -1. So g of 2 equals -1. That's what I'm going to replace g of 2 inside the parentheses. So now it becomes f of -1. G of 2 got replaced with -1. And again, we go back to the table to find f of -1. So when input is -1, when x is -1, what is their corresponding function value for f? Well, right here, when input is -1, the function value is 8. So the answer is 8. In example C, composition of functions f and g of 2 equals 8. So this is how the composition operation works. Basically, you need to know the definition of this operation, you need to know how to write it out. And once you write it out, you start working from inside out, obtaining each value using whatever you're given, equation, graph, or the table.